1, 2, 3. Sound check. Hello everyone. Hopefully this works. So today we'll take a look on this SRS low noise amplifier. It's a voltage amplifier. So I got this box a while ago. Thanks for friend support, and I didn't take it apart before. Didn't do anything other than just visual check that everything is there. So we will do all that and also look inside of this unit, do some tests, see if we need to do some repairs, because these amplifiers come with a battery internally. I would expect this battery is dead and maybe there is some corrosion. So we'll have to do some investigation and see what we can find out, if there is anything wrong. And then we can do some tests with the oscilloscope and signal generator. And that's about it. That's the plan for today's stream. So this manual is pretty detailed with some of the specifications, theory of operation, and even a BOM list. And we do also have a schematic for SR560. So this will be a deep dive in this amplifier design. And hopefully the sound and video is all good. I'm recording this as well to the memory card, so we can make a probably later shorter version of this. Alright. Let me share this link to the XDev's IRC, which you can always visit to check discussions around electronics, metrology, repairs, test equipment, and overall stuff like that. Alright. So it looks like there are just some screws on the outside on the cover. Should be pretty straightforward, and the front panel is quite yellow. Maybe I'll take it and whiten it up with peroxide and UV light sometime in the future. But for now we can take a look at the controls. So there are BNC differential inputs and as well as output. So outputs are 600 ohms, inputs are high impedance, 100 mega ohms, 25 picofarad. From what I can see from the labels, we can set a different frequency for high pass and low pass, select the coupling for either of the inputs with AC, DC or ground, and invert the B signal, and we can do A or AB or B input selection. As well as there is a gain selection and different mode separation for low noise or either high dynamic reserve. There is reset for overload and battery or line switch. So we can turn it on, and as expected, nothing happens. So let's take a look on the back. So on the back, what we got is there's a mains transformer here. There is the mains input, DC power input, so positive and negative 12, fuses for battery, ground chassis, and blanking in BNC input, as well as RS232. And there is charge or maintain charge status. So let's take covers off and see what's inside. But before I do that, I'll probably take some of the picture of the front panel. So let's do that. Can use my trusty camera with the macro lens GF120 to do the photo of the front panel. So let me put everything on tripod. It should just take a little bit. I always try to document the condition before and condition after for article. I never had experience with SRS equipment before, so this will be an interesting look inside of it. Alright, adjust the focus. I do all the manual settings, so minimum ISO, tripod, optical stabilization off, timer on. F11 and exposure time 1/3 of a second. We should do the business well. All right, maybe one more. And then the same photo on the back. And photo is done. And actually, the interesting to note that the BNCs are actually floating. The dead giveaway is a plastic washer around the case, so this is actually pretty handy for sensitive measurements where you need to avoid ground loops. Okay, there is a fly flying around, which I'll need to catch. Now pictures are done. Let's take a look at everything nice and sharp. By the way, if somebody in chat knows HDMI recorder for 4K video, that would be very handy, because I still use my old Full HD recording setup, but now with a better camera I would like to record live streams in 4K as well. So if somebody knows a decent solution that is not too expensive, let me know. I would appreciate that. All right, time to open this box up. And so just a Phillips screwdriver, that's all it takes. I see some cracks on front panel, like here, here, there. So it hints that it's a bit fragile. So we'll try to be gentle with it. And this should slide off or lift up. Yeah, it slides and lifts. That's the deal. Okay. I guess this is the holder for batteries or spacer. There is a cool label here. Says calibrated 27 May 2014 and due 27 May 2015. So pretty hefty metal plate. And I guess this is where the battery should fit. I'm interested what kind of size of battery it is. There's a label. It says 12 volt, 2 amp hours battery, lead acid. So, okay, I guess this slides off like that. Pretty cool. And then the battery bay lifts up like that. Oh, nice. So this is, I guess, all the battery connections. I actually do have a handy battery in here. So this is 12 volt 7.2 amp hours for Flux 732B. But I think you need to use actually two batteries, because there is a bipolar supply required for this amplifier. So there is a ribbon cable going to the front panel, and the board is mounted with all the components facing down, which is actually pretty cool, because you get access to all the pads. But also, if you remove the bottom cover, which we can do now, we also get the access for all the business parts. It's rather clever design, easy to service. Well, my camera can output 1080p as well, which it does right now, because otherwise I wouldn't be able to live stream. But I would like to have 4K, or even record in 8K. Obviously the files would be huge, and with my slow internet it might take forever to upload, but could be cool for some fancy teardown equipment. Okay, let's slide this one off. I don't want to lift it too much, because this would happen. I would break the plastic bezel. I would say this is probably like 1.5 millimeters thick panels, and also this black chassis is quite hefty. I already see the pieces crumble. Come on. There we go. So nothing on this panel, just the mount holes for legs of some kind, and here we are. Pretty much you don't even need to take the board out to replace any of the components, perhaps except the connector or some wires. So there is the power switch. Let me get a better view for you. So we have the power switch, some of the relays for the input, those floating BNC jacks going here, some trim ports, some of the ICs are in the sockets. So this is OPA 37, this is NGS NPN 5564. Looks a little bit DUI marking, but this probably some dual JFET for the main preamplifier, given its proximity to the input. Then we have some more trimmers, DG444 multiplexer, LT1028. This is a very low noise amplifier, very typical part for low noise designs. Some more of the latching, all these yellow relays, they are latching. This, I guess, regular relay. A bunch of decoupling capacitors, some more relays, a bunch of digital logic. This is the firmware EEPROM. This is probably main processor, TMP Z84C00 from Toshiba. This is SRAM, I believe, power supply capacitors, rectifier and mains transformer, some switches. What else? So there are regulators, linear regulators, LM337 317s, and here too, mounted to the chassis. There is no fan in this instrument, so everything is silent and quiet because it's relatively low power. So pretty nice and clean design. There are some capacitors, probably film capacitors or mica capacitors. Given their different size, they are probably setting the filter bandwidth for low pass and high pass. So even without looking at schematics, we can figure out many of the things already just visually. So I think I'll take the front panel maybe apart to see what we can find there, but we can already check if it's yeah, I don't think that would be easy front panel removal because all these wires are rather short and connected directly to the PCB. So we can plug it to the power and see what it does. So unless we don't have anything else here that looks broken, but there are a lot of tantalum capacitors, like all these yellow beads all over the board. These are little tantalums. I would be very tempted to replace all of them. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 23, 24, 25, 26, 27, 28, 29. So about 30 capacitors or so. Probably all of these electrolytes just as well. I don't see any leakage around them, around these ones either, but this instrument was built in 1999 based on date codes that I can see around on the chips. So end of 1998, 1999, and I would say all these capacitors are required for replacement if we want to have this instrument be running another 10 years. All right. So this can actually disconnect this cable here. It's a keyed power connector. So I would expect how many battery terminals? 6. Okay, that's interesting. They probably used 4 of 6-volt batteries, because actually whites are all connected together and reds connected together, and there is one black one. That's kind of interesting layout. But going to the main board, just 2 of the white ones, black and red. So this should be pretty traditional bipolar supply. I will take a look on manual to find out what batteries are needed. Or maybe somebody already had one of these SR560 opened up before, to let me know which battery I need to get. Zoom in camera about 10%. Well, I can try that. Let's see. Well, not really, because I'm already at 64 millimeter. So this is 32 by 64 lens. I can try to move the camera just a little bit. And what happened now? My streaming setups are still need work to be done. Okay. Can just try to reposition the thing a little bit. Just like so. Is that better? Well, let's get the AC source going, and then I can try to power this thing on and see what we get. So let's see what's the setting for 110 or 220. So there is a little tag that I can pry off to investigate. Probably with some tweezer. There's a fuse pull. These front panels out of the way. Okay, so we had 120 set. And check the fuse. Make sure it's okay. So for this I'll use my trusty Keithley 2002. And fuse reads 0.3 ohms. Sounds like a good value to me. And let's actually check what's the value of the fuse is. 250 volts and Bussmann fuse. I don't see a current rating. Yeah, there is no current rating. Let me do it from this side. There we go. Now turn on the power source. I use Chroma programmable AC source model 61604 for all my tests for test equipment, because I never know. Maybe this transformer is blown, maybe some other issue. You don't want to have instrument with an unknown condition plugged into the mains to avoid more damage. Rather current limited variac auto transformer or the programmable source would be very handy in cases of unknown repairs. So let's power it up and see what it does. So the rating on the back says line fuse 1 amp for 120 volts or half an amp for 220. We can set the limit to 1 amp at 120, 60 Hertz mains, and see what it does. Well, my question about the batteries was what exactly type in terms of the size and model number. So you say that page 55 has showing 3 batteries. I'm not sure which one is page 55 here. I didn't see any drawings. There is a section for battery care, so can be powered from either AC power source or from 3 12-volt batteries, 1.9 amp hour batteries, integral battery charger. But like what size of the batteries are they? Because I never used such thin batteries. There is probably, let's see how much space there is. So for thickness, let's say maybe 30 millimeters height in this panel. So those are pretty slim batteries, I would say. right in the end. Well, in the end, at least in the manual, the copy that I have, just a BOM list. But where is the battery part type? See fuses, housing. So maybe somebody can post if those batteries are actually available. So I would like to get this unit to 100%. Anyway, let's go back to the powering the thing up. So 120 volts. Let me program the limit to 1 amp. Current limit, right now it's set at 16 amps. What we will need is 1 amp. So 1 amp, there we go. Okay, so I turn up the unit and it's drawing 2.5 watts or 0.003 amps according to the reading from the AC source. And nothing else is happening because right now it's off. So let's turn it on. And we have LEDs, really faint looking, because I have quite a bit of light in here. And it's drawing 11.6 watts or 0.13 amps. So I'm not sure if you could actually see it. And yeah, of course I don't have autofocus enabled. So let me find some spacer. So I can actually set the camera to focus. Interesting. Yeah, there was no link in here. I can set you as a moderator. There you are. Now you can manage. All right, let me set the camera to focusing. There we go. And you can kind of guess can turn off the light probably. Oh yeah. So that's what it's showing. So I guess it's time to fire up the oscilloscope and see what it does. Okay, regulator is getting pretty warm on the side. No smoke coming out, so that's always a good sign. What I can do, actually I can measure the voltages at this terminal. just so we can see if there is something reasonable in there. That's 14 volts positive between white and the red one. Let's see. White and the black one, minus 14.05. So that sounds about right for a charger. Let's keep this. I can put it in a little bag, just so I don't short anything while I'm messing with the instrument while it's open. Now we should be all right. Yeah, regulators are warm, but not hot. So let me actually see if I cannot set anything or reset anything. There is no reaction to the buttons whatsoever. I don't think this is correct operation. There is just overload LED light, and hitting reset does not do anything. So I think we do need some repairs. Unless it requires inputs connected to something or like terminated, but I don't think that is the case. So no reaction to the front panel buttons. We can try to reset this firmware chip. We can try to read it, because this feels like a firmware or digital issue, because there are a bunch of these filter cutoffs LEDs all light up together. That's probably not how it's supposed to be working. So let's see if there are any power rail markings. So there is clock, AGND, battery GND, plus minus 12, test points, so we can measure those. That's probably the ground. Right, plus 12.149, minus 12.13, so that voltage is good. And what else we can measure? Well, I guess it's time to take a look on the manual to see what we can find there. There is a self-test procedure. So before we're going to do that, we can take a look on the overall block diagram, which is provided in the manual. So what we got here is two inputs with a switching ADE and AC or DC coupling, and the main low noise amplifier, filter to select either high pass or low pass bandwidth, or also to bypass the filter altogether. Then we have the post amplifier, we have a second filter, also high pass, low pass in the same frequency bands, output amplifier, buffer, and then the output to I guess two outputs. One is 600 ohms, one is 50 ohm. Okay. And that's why we have two BNCs for the output. They have different impedance, and we have separate microprocessor system with front panel, input output strobes and latching, that's for the control, power supply, and optically isolated RS-232. So that's all about there is in this instrument. So there could be also a problem that there is no battery connected, and there is some detection for the disconnected battery, and that could be like a protection mechanism, but I don't think that's the case. I hope that it should be functional even without the battery. Let's see what else in here. Power up. All instrument settings are stored in an NVRAM. RAM backed up and retained when the power is turned off. Okay, so there is a self-test. If the power on self-test passes, the unit will return to the setting in effect after the power was last turned off. So apparently there is a self-test procedure. Let's see. Battery life, 15 hours nominal. So when connected to AC power source, amplifier power is derived from regulator line power, and internal batteries are automatically charged. Charging status is indicated on the rear panel. Okay. Status, filters, reset. Overload LED indicates signal overload. This condition can occur when a signal is too large or dynamic reserve is too low, reducing the gain, reducing the input signal, and or switching to the high dynamic reserve setting should remedy this condition. If overload occurs with filter setting of long time constants, the reset push button will speed the 560 recovery from overload. Okay, that does not help us in this case. So AC power input, battery charger, battery care, we don't care about any of that. There's a pretty decent description of the circuit. Power regulators. So +5 and +10 supplies are produced with 3 terminal regulators U801 and U802 respectively. The -10 supply is constructed of op-amp U803 and Q801. 10 volt supply plus 10 volt supply serves as a reference for -10 volt supply through divider R807 or R806. So I guess we can check these power regulators around U801. I believe these should be somewhere here. See U706, U702, or maybe they are closer to here, where all this bunch of capacitors are. Or here. This IRF, that's that pass transistor for -10, and U802, 801 right there. So they are here and here. So we can measure the voltages there. Let's turn on this thing again and poke around. So which one would be the ground? Can try the chassis first. Let's see, plus 12, yep. Let's see, pin 1. So input is plus 12 and the output is plus 5. So we do have 5 volts. And then the plus 10. For plus 10 they use LM2940T. So input is 12 and output is plus 9.953. Okay. Doesn't look like anything wrong with that. Let's see this pass transistor. So minus 8 on the gate, minus 9.93 on the tab, and minus 12 on the third pin. So I think minus 9.9 is also sounds about right. So we do have minus 10 plus 10, no problem there. Alright, there is also 7. Hello, how are you? Doing good. Trying to find out why this low noise amplifier is not working correctly. So there is a little bit of microprocessor stuff. System processor U503 is CMOS Z80 processor running at 4 MHz. System clock consists of Schmitt trigger U506 NRC network. Oscillator designed so the latch U508A can shut down the clock oscillator completely, thereby disabling all digital circuits in the amplifier, so there is no digital will be present. That's nice. The processor and clock only run when the front panel key is pressed and instrument settings are to be changed, or where there is activity on RS-232 port. That is pretty clever. There is 16K by 8 CMOS EEPROM U504, which is, I believe, actually this guy. So this is just an EEPROM containing system firmware and calibration bytes, along with 2K by 8 CMOS RAM U508, 505, which is battery backed up at all times to retain instrument settings. I guess it's this guy. Yep. But there is no little battery, so I guess it's battery backed up from the main battery. But it's just the retain instrument settings, so we shouldn't be worried about that. We can also take a look on the schematics, just to see what's this SRAM requires. So here's the schematics I printed. Where is that memory chip? Let's go find it. Okay, so this is the processor, EEPROM, RAM, and the VCC goes to diode connected OR, so it's either VRAM, I guess voltage for RAM, through D503, or from the VCC main rail that powers everything else. So we don't need a separate battery power for that thing. We can check that oscillator is doing anything on the clock. So when I press the button, I expect it to wake up. So let's turn on oscilloscope, and then I can I see the test pad CLK. That should be our giveaway for a clock. So let's see that the scope boots up. My good old DPO 7104C, and see if that does anything. And this EEPROM, I want to read it as well, just to see. So for those who just joined, we are taking a look on this guy. which is Stanford Research low noise amplifier. Let me get the focus in. Yep. So it's SR560 low noise voltage amplifier that can be battery operated or can be mains operated with two inputs, output with two different impedances, and selectable low pass and high pass filters. Here is the circuitry around it. Pretty nice and clean design. And we have the front, and this tangling wire is for battery bay that is right here. I don't have original batteries with it, so I'm powering it from the AC power source. So let me get the scope going, enter my super secret password tag. All right. So I've turned the power on, and it comes up with filter cutoffs. LEDs light up for 10, 30, 100, 300, 1K and 3K all the same time. So, and the instrument does not react to any of the button presses, like nothing happening. And there is overload switch or LED showing up, and switching the reset button doesn't do anything. So this is the condition we are dealing with right now, and I would like to check if there is a digital activity when I'm hitting the buttons as the manual say it's supposed to be. So I'll just connect the ground clip to the chassis right there, and we can take a look on this clock and see what's going on. Here you see my battery link before to show what it uses. Well, let me take a look. Okay, also nice that there is somebody else had the problem with overload, so I'll check that link in a second. Okay, I am seeing this battery. This item cannot be shipped to your selected location. All right. On page 17, you can see now that most commonly component is U106 and PD5564. Okay, I guess that's that JFET that's right in here. Let me take a look on the article. I'm pretty sure this part is obsolete, but let's take a look on schematics as well. Is your lens still working? Yes, actually you are looking through the camera, that is has that lens from the last live stream attached to it. So it's still okay. Alright, I see some clock signal on my scope. Let's see. It looks kind of weird, and it's changing frequency as well. So that doesn't look very nice. So the duty cycle is not uniform, or rather not 50%. And also, let's see, the frequency. So frequency changing between 130 Hz and 141 Hz. So kind of bizarre. So let me hit some buttons. Oh, this is actually with instrument off, or rather I guess it's never off, because even though I have the power. Okay, that makes sense now. Maybe not. Oh wow. Yeah, this is some weird stuff. So there is a funky looking signal. Let me actually connect I don't want to move the camera to show you the oscilloscope, but I have a second HDMI capture card, which if I can find the suitable cable, probably DVI to HDMI, I could connect the scope to it and we could switch to the scope. So give me a little bit for setup. I can also move the webcam that I have. Oh wow, that's a lot of noise. Somehow. Let's see. Oh wow. It's just background clip. So this is a. Let's flip this upside down. How do I do that? Okay. Transform. There we go. So this is with the instrument off, or rather in line mode. And if I click the buttons, the duty cycle changes a little bit. But if I turn it on, it becomes that, which is 4 MHz signal. With a decent duty cycle, so kind of interesting. And now the instrument is off. So there is some activity. Let me see if I can connect the capture card to scope. So I need HDMI to DVI. Let's see a DVI cable. But this is just DVI to DVI. It doesn't help. Oh, there is, okay, this is DVI to display port. Also doesn't help. Yeah, doesn't look like I have suitable cable, unfortunately. So that's about that. I'll put it down to get for the next time. So we can try to read this firmware. Maybe it's just the firmware that is bad. I can also take this dual JFET out of the instrument, because this dual JFET is on a socket, so it should be fairly simple. So the JFET that is in the question is this right here. So this is a front-end preamp of the low noise amplifier right at the front. So there is the post amplifier after it, and there is the inputs A and B going through some AC or DC coupling relays. Also this is an inversion function, so it just flips around to the connection, and here goes right directly to the gates of this dual JFET. With some biasing on the plus 10, minus 10, with some current sink for this whole setup. This is fairly traditional circuitry for low noise amplification with a discrete JFET preamp stage for differential input. We can actually replace this JFET with something modern, like say LSK 389 or 489, or even low noise interFET, like for example IF 3602, because I'm pretty sure the original part is impossible to buy now, because it must be long time obsolete. But just for the idea, we can pull this chip out and turn on the instrument and see if it actually changes the behavior. I don't see much of the harm doing that, so let's try that. The sockets in these instruments are very nice, collet type. None of that spring-loaded stuff for the important signal at the front end. So now we have JFET switched off. Let's turn it back into the power. Okay, I heard the relay click. Let's turn it on. And same behavior. So nothing changes. We can plug the chip back in. Same behavior. So let me take the firmware chip out and see if we can read it and if there is something that looks like a firmware. This is a EEPROM UV erasable. That giveaway is a little detent for the window, and a sticker that protecting it over. Before I remove the sticker, let me take a picture of this whole thing. I'll need a little bit of, oops, there goes the camera. Let's see if I can fix it better. Let's see if it still works. It's frozen. There we go. So I'll just take this photo, and then we will get back to the firmware. If the firmware is okay, my next step would be probably to replace all those tantalums and together with electrolytes, and that will probably be a segment for the part 2, because I'll first need to buy all the caps, because I'm pretty sure I don't have all of them, all of the values and sizes that are used in this instrument in stock. So it might be a lengthier project. Alright, let's take a picture. Obviously this and all the other photos of this project will be published online on xdevs.com in a repair section. Okay, image is done. Now we can do the other side. Get the cable out of the way. Can detach this ribbon cable. Oop, I just broke the latch. So this latch is very fragile. Actually, one side was already missing it, so probably somebody was here before me. Let's take another photo. I see some of the solder flux around few of the chips. Like there is a solder flux here, here, in center. So maybe somebody was already replacing some stuff before. Alright. Also I want to take a photo of the condition as it boots up, to show the exactly LEDs that are displayed. right. I guess another thing that we can do is to measure what's on the output, just in case, if there is any signal in there. So I can easily do that. Let's connect this. Oops. Camera died again. Wake up. Let's see if I can find something to hold on. There we go. So channel 3. Let's see what's in here. 1 mega ohm. So let's connect to the output. Okay, so we have some DC level at the output. RMS. So we have plus 7.1 volts. Let's just make sure that all the... Yep, it's 1-to-1. 7.1 volts, negative at 600 ohm output, and same 7.1 at the 50 ohm output. And if I turn off, then it goes to some millivolts, so essentially 0. Turn on, goes straight to 7.1. And let's see what's at the input. Nothing at the input. And the second input, also nothing. So we have fixed -7 at the outputs. That also suggests that something is broken, because I don't think that's supposed to be happening with no signals attached. Okay, what's going on with the camera? Battery died. Let's check. Have to walk around the back of the bench. No, battery is fine. Just something tripping off. All right. So let's check the firmware. If I can find my little screwdriver. Wiggle it around. There we go. Now I need my programmer. Might have it hiding somewhere. Give me a minute and I'll come back. And we got my programmer. So this is good old TL866 CS. Works for 99.95% of all the stuff I need to do. Let's get this sticker out because I need the part number. So the firmware chip is, I need a microscope to see this. We need the USB cable. There's a USB cable. Let's plug it in. All right. Okay, now I need to actually install the software for TL866 on this computer. So the chip in question is, let's see, it's AM27064-255 DC. Date code 1998, work week 51. 12.75 volts PGM. I guess this is the programming voltage, and it's made in Malaysia. So that's what we need. Let me install the software. Should be easy to find. TL866 TCS programmer download. Loading up. Application software version 685. Mini Pro. Slowly downloading. I actually have 616 on my server. But I guess we can use the latest one. If it downloads, takes good 6 kilobytes per second, super slow. So 18 minutes left. I'm not sure I want to wait that long. Is there anywhere else? Let's see if it's on my another machine. Doesn't look like. No. Yep. Now it's 24 minutes, even slower, 3.7 kilobytes. Is there any mirror where I can get the TL866 software? Well, I think the power rail's probably not it, because this feels like a digital issue, since like no reaction at all. Well, I don't want to wait for this to download forever, so I'll just go and read this chip on my another computer, and we'll be back shortly, because I already have it installed in there. All right. So the chip name, I already forgot what I was saying. AM27064. Let's see. Let's plug it in. 7F. Oh. C409. Some to ED602. This box which times 8 checksum to ED602. So there seemed to be something. Audio gone. Audio should be fine. 1, 2, 3. Hey DevPong, I have a question for you. Is there a particular reason why you don't show up on our little chat? You do a lot of repairs and it would be fun to chat around. Especially I'm particularly interested in your experiences with DMM 7510 because I never had one to play with and it seemed to be a pretty capable instrument from what I've gathered so far online. Okay, I've put the chip back in. It's an XDEV's IRC. So if you just have the IRC client, I use HexChat. You can connect to server at xdevs.com with a port 4808. So 4808. That's the custom port, just to avoid the bots and spammers joining. And there are about 20 to 30 people. We talk about test equipment stuff and different projects everybody doing. Sometimes there is some lively discussions about things, sometimes not, so could be fun. Anyway, I put the chip back in. Let's turn it on, see if anything changed. Probably not. Nope, still the same. So let's take a look on the schematics more closely to see if there is something obvious we can test. I want to see the front panel first. How is the communication is done between the brains and the front panel. Okay, so digital I/O. There are some switches to set some modes, I guess. There is a parallel bus that goes to a bunch of the latches. I guess those control all those LEDs. And that's about all she wrote. Battery charger. So battery charger gives the voltage for VRAM. We can measure the voltage at that memory chip just to make sure it works. Should be 5 volt there, I guess. Okay, there is power regulator and rear panel. That should be fine. I can also power it from the battery inputs for DC voltage, but I don't see any difference that it would make. So let's see the voltage that is present on the SRAM chip, because that would be kind of important one. So there should be 2 diodes, D503 and D501. So 503 is here, 501 is here. So we can measure, or just measure on the pin 24. That should be the corner pin. Oh boy. All right. Let's measure the voltage, turn the thing on, and pin 24 should be this guy. We got 4.597, so that sounds about right. The drop after the diode, and D501. So voltage is 502, and after the diode it's 4.6, so that's sounds about right. Could be bad SRAM chip as well. Did happen before. I guess I can try to see if there is any activity digitally on that SRAM chip. Let's try hook it up, pick some data line. Well, it's not the dodgy HDMI connection, it's the there is a certain time limit, I think, on the how much of the footage can be recorded in one go. So that's what's happening, is camera stops recording and then enters the power saving mode. I'll need to fiddle with the settings a little bit. So let's see, pin number 9 for example. 4, 8, 9. Okay, so there is some weird looking data going. That doesn't look right. Okay, so that looks better. But this looks kind of strange. Let me show you what I'm seeing on this scope. Channel 2. It's kind of bizarre. So let me set up the camera again, the web camera. And also probably a lot of glare. Sorry of the junky setup. I'll make it better. So here is the pin number 8. So looks like some data stuff going. Doesn't look too bad. Oop, my keyboard is clicking. Again, pin number 8. So it looks like kind of like a data stream, but pin number 7. So some activity, but pin number 9. Okay. Okay, look at this thing. So what are all those notches on the top end? That doesn't look like the right thing. Let's see. Just want to stop it. Okay, there is the single. So that doesn't look like a correct data transfer with all those notches. Let's see other signals. Yep. And what the hell is this? This is pin number, let's see, 4, 8, 9, 10, 11. That's pin 11. Pin 11 is supposed to be data 2 line. So this is pin 12. This should be ground. Pin 13. Pin 15 also looks wonky. 16, 17, 19, and this. This is supply. So supply looks weird a little bit. So something is going on. I can try actually different ground. Maybe it's a grounding issue. Let's see. So pin number 11. Okay, let's see this crazy one. Nope. Still the same crazy. So now I'm tempted to see the power. Whoops, sorry. Okay, minus 21, but going with this wobbles. This I'm measuring one of the caps. Let me fire up the DMM. Okay, so I want just to measure some voltages. So minus 24. Here is plus 24. D2 line, yep. RTO8. What's the RTO8? Ah, RTOS. Yep, I love my 2400. I have actually 2400 and 2425. So they are used very often. So I guess I can take a look if I have these caps here, and let's see what's these other ones. 100 volts, 100 microfarad, 63 volts. So I'm pretty sure I have those. And this should be very easy to replace because we have the full access from the back. No need to take the board out. All of these seem to be across all the analog power, so I don't think those would actually matter. Because like even if something analog front end is not working properly, the digital and all the key operations should be still fine. So I would replace these guys and see if we can get any changes, because those data lines, they look pretty crazy. And I'm pretty sure I have this memory chip as well. So this reminds me Keithley 2001 repair, because they had this LH5116 memory chips. So let me take a look in the drawers to see what I can find. And this pesky fly. I'll get you. Anyway, back to the caps. So let me see if I have caps. My little capacitor stash. So which ones we need? 1000 microfarad, 35 volts, axial capacitor. I have some axials in here. This one is high voltage. Now we can just toss everything on the table. Since we can also look on some of the other values. So 100 microfarad, 63 volts, and axial caps. D2 goes to EEPROM pin 13. Well, I was measuring at the SRAM chip. But I would expect that data lines share for the both EEPROM and SRAM together. So this is why I always try to start repair with capacitors, because if you replace all the new capacitors, then you are for sure not doubting yourself if it's power issue or if it's some other problem. And power issue, I mean like ripple or noise, because like so many instruments were the only problem they had was the bad capacitors. I'm running short on the bags in here. Have a couple more boxes where the caps often live, so let's check those real quick. XL caps. There are some big ones. And this capacitor is used in 3458A. You can always put a usual radial cap just for testing. Like for example this guy. So it's 1500 microfarad 50 volts instead of 1000 microfarad 35 volts. This capacitor is used in Keithley 2001, 2002. Big caps won't be cheap. Well, relatively speaking, it's I don't think that would be too expensive. Maybe a couple dollars a piece. But even if they are like $10 a piece, like it's still, we are saving a rather valuable instrument. So those are inconsequential, in my opinion. So I'll just put some of the radial ones, because if it works, then we can worry about getting the proper part. So we need 1000 mics. These are 680s. They're actually even slim enough that I can just put them kind of sideways. That's fine. So let's put two of these guys. So negative towards there. This would work. Let me get my soldering iron. Back to no signal business again. Fume extractor, because I don't want to breathe any of those fumes. So I use the toothpick to clean up the hole while I'm heating it. There is a positive plus marking on the PCB seal screen, kind of handy. Alright. One is in. One more to go. Could be also one of these tantalum guys, but again, like tantalums usually fail short. So that would be like too low power signal, not this crazy nonsense with digital business. When the ones are not exactly ones and zeros not exactly zeros. something like that. So I want to take a look on what are these C710, C709 doing, where they are. Probably somewhere in the charger section. So I found 707, 706. They are across the main regulator for the negative prereq, battery common, and goes to the plus line, and yeah, positive and negative prereq. And VRAM is fed by this regulator 706. Okay, so they are 708. So 709 and 710 are inputs of the two regulators that supply the whole thing. So we can take a look on what's else happening around digital section. So there is oscillator. There's a little adjustable, this 502 adjustable capacitor. That's, I guess, for the frequency setting. We can measure the clock again. G541 clock test point. But like, I mean, even if the clock is different frequency, it should still be working properly. Just the RS232 wouldn't be right. So we can take a look on VCC5 just to see if it's actually clean enough. Let's power up. Where is that silly thing? Same effect. Now, wouldn't be it nice? Come on. If somebody who has the same unit would actually dump the firmware, so we could compare that the firmware is correct. That would be rather useful. Anyway. So yeah, the 5V doesn't look too great to me, I would say. There is some ripple in there. Let me show you. That's the 5V. So if I switch the scope to IC coupling, let's see. Let's see, couple. So measure peak to peak. Channel 2. So there's a ripple around 700 millivolts. So that does not look like a healthy digital power rail. So I would say, let's take a look what feeds this 5 volts. So it's a VCC power rail. Now we can take a look where it comes from. So plus VREC goes to VCC, and plus VREC is fed by this LM350, which has a little tantalum guy, C708. That should be right there in the corner. And we have a regulator, LM350, and we have 100 microfarad at the input of it. So, alright, and the tantalum is 2.2 microfarad, 35 volts. That should be easy enough to replace. And these two caps are just found a newer manual, same revision F. Well, feel free to link all the manuals in here. So I will definitely download and archive everything. Anyway, back to our business. So there's 2 tantalums and 2 of the electrolytes, 100 microfarad, 63 volts. I can find something suitable. 100 microfarad, 63 volts. I need something skinny enough to fit within this footprint. I think this might be a little bit too tall. Or maybe it's fine. Yeah, that should be fine. So these are 330 microfarad, 63 volts. So much bigger capacitance. Nichicon ZLJ. I bought these for Agilent N5182 repair. So I'll just use these two. All right, let's get going. And actually I can put the capacitor on the other side of the board if I ever need a taller space, but we should be fine from the proper side. Quadro 630, is that a graphic card? Check the polarity. Okay. Now both caps are in. Let's clean up the mess after ourselves. Where's my stash of Q-tips? I guess I can use some cotton instead. Okay, now let's take care of the tantalum. So I need 2.2 microfarad, 35 volts. Let's find something suitable. So 4.725, 4.735. Let's look around some more. .8, 2.250 volts. I like these ones. So same capacitance, higher voltage. That's what we want. So now I need to pay attention and not mess up the polarity, because that would be a nasty firework. Let me take a look. So positive marked as with a tab. Yep, positive marked with a tab, so it's towards the connector side. So let's get rid of the original one. And it just falls off like that. Alright. I need to heat up the hole from other side and then stab the pad with a toothpick. Now I have two good holes. Let's plug the capacitor in. Positive towards the connector. It's hard to grab at the proper angle. There we go. Now it's in. You can swap for the negative regulator as well. To reach okay. Okay. Quadra and centers. I have no idea what are those. Now the main question, will the power ripple will be gone after this? Now I'm tempted to actually try it with DC supply. I can just hook it up to Keithley's SMUs, positive and negative, and see if that gives any change in behavior. Because technically, from the DC power, you would not have the AC ripple from the power supply. Unless something else is oscillating and making that noise on the power rail. Well, that should be good enough. Shall we try again? Why this capacitor is so tall? I guess legs moved when I was messing around with it. Okay. So I see the replaced chip was LF356, and I guess there was a couple more. So this was also replaced, AD7528, that sounds like a DAC, and this chip is not even flat, also LF356. So something was fishy going on. So this chip, and this one were replaced before. Anyway, let's plug it in, see what happens. So I've replaced these caps, those tantalums, and these two. Let's plug it in. Yeah, you're right. It's not much of the 3.3 mic. Nope. Still same. Let's see if the ripple is still crazy. Yep, still crazy. 720 millivolts. Well, let's try DC power now. Should be easy enough. So turn on 2400. And I can connect. So ground plus 12 minus 12. All this set up. Camera for you to see better. So we can program to 12 volts, say 300 milliamps. That should do the trick, because on the back they say switched amplifier power I out less than 200 milliamps. And this would be negative 12 volts. And also 300 milliamps. So let's plug in our rails. So here is the setup. Have positive and negative, and goes to the SMUs. So now I need to toggle them both at kind of the same time, plus or minus. So let's do this. Okay. And no changes whatsoever. If now it's in battery mode, it shows battery light, the same as before, and power switch does not do anything. So let's measure their noise again. If it's changed at all. Nope, still same crazy. Let's see some data lines. Need to switch to DC coupling back. Give me a second. Still crazy. Like, what kind of digital signal is that? Maybe it's bad CPU. This one is okay. At least it looks okay. Here's the clock. Because like some of the, like this one is fine. This one is fine. This one is fine. We can take the firmware chip out, see if it changes. Can try that. So firmware chip is out. Let's see. I also want to solder the ground pin to some proper ground instead of the chassis, just in case. So let's see which pin I can use for ground. Pin 1 of U510, for example. Or the C816. Where is 510? Yeah, this one. Pin what? Pin 1. Okay, I guess I can solder to that. I just soldered a little pin. So now we can probe nicely. All right. Let's get the power back on. Okay, without the firmware chip, noise looks slightly different. It's much smaller, but now we have this oscillation. Because like CPU probably trying to start and there is no firmware. So we have this funky looking signal, which is, let's see on the data lines. Data lines quiet with some of the ripple, some of the pulses going crazy too. Wow. So this is just CPU trying to cycle. Oh, this is almost like a 500 kilohertz square wave. This one is 248. This is like some trains, pulse trains. So it's kind of bizarre still. And that's the clock. 3.988 megahertz. I can probably fine-tune that cap to exactly 4. Yep, now it's more or less 4. Not that it matters. Oh. I'll try to nothing get hot, but nothing works either. So, any ideas? Let me take a look on the memory chip if I have one. Because if I have this memory chip, I'll just replace it. Might be relatively quick. I did had some repairs before where the memory chip failed. And the question is, where did I had the one like that? No, I think I found something. This is not it. This is 5168. Probably different size. These all are from Keithley 2002 repairs. 5864. Let's see, I might have from 3458A. I need to find my box with 3458A parts. I have some memories, but they seem different. I do remember that memory chip somewhere else too. Well, what should we do? Check reset. Okay, that's a good idea. And I think I'll put the mains back in. It will be just easier to turn everything on and off. So you say check reset. Let's check reset. So the reset is pin 26. Driven by inverter. And where it comes from? Well, let's just measure it first. So, where is my power cord? So, pin number 2 of the U501A. U501, this one, pin number 2. So there is pin number 2. So turn on, reset, goes high. There is a little ripple, about 170 millivolts on top of it, but it's high, 5 volts. And pin 1 is kind of around 0 with a big ripple, around 340 millivolts. So, and if I turn off, it's kind of floats in the middle, around 1 volt. Turn on, goes 5 volts. So about 1 volt when it's in battery mode, without obviously a battery. So reset is present. Let's see the VCC pin on some of the pin. 74, pin 10, U508, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's our power rail. So the power rail is 1 volt. When there is when IC applied, it's 5 volt, pretty nice and stable. Very small ripple, but when it's in battery, then it's 900 millivolts, more or less stable. So there is our VCC, you can see on the screen. Let me move the camera just a little. Sorry about all this camera business. So this is 8, 9, 10. Pin 10 of U508. So turn on, 5 volts, more or less steady. pretty good. Turn off, and it goes to 1 volt. And this is a ground potential. So I can actually connect the plus minus 12 from SMUs and keep the AC power on, so we can see what's going on in that case. Maybe you do need to have both power sources, but like it's just so strange with all this business going on. Positive, negative. Okay, now AC is plugged in, and I'm turning on SMUs. Okay, SMUs are on, so we have 5 volts. We have both LEDs light up, and now I can switch on. Nothing happening. SMUs actually sinking current now, and if I turn off, they are sourcing current. That feels about right for the charger operation. So you can see positive current means they are sourcing. Now negative, they are sinking. And the VCC rail does not change. And obviously no change in behavior in terms of the buttons and stuff. Let's see the crazy signals on memory. Yep, still there. All this weird stuff. Maybe it's working not digital logic, but multi-level logic. But no. Could be bad CPU as well. So my next probably candidates would be to replace the memory chip, replace the CPU, try to find the firmware somewhere online, maybe from some other user or owner of SR560. So that would be my next steps. So I would say we'll order the capacitors. Get the proper capacitors for here, replace all of these guys, replace all the tantalums just in case, get the new memory chip, new processor maybe from eBay, try to find the firmware chip, and then we can try again. I guess that's about all we can do at this point. So if any questions, feel free to ask now. And I'll read some more in the manual as well as schematics to take a look what else we can we try to troubleshoot. Maybe it's one of the logic chips is bad, but like on the data bus there is nothing except processor, 2 memory chips, and that's about it. Like the data lines go to just this stuff, and it also goes on another page, probably for the for the front panel as well. So we can actually disconnect the front panel and see if that changes waveforms on the data signals. So should be easy enough to check. Because the front panel just LEDs and keys, and the power switch is directly connected to the main board. So let's see, same crazy signals. Yep. Still same crazy. Now I can actually cut one of the pins from memory chip and see if the crazy goes from the memory chip or is it goes from CPU. But that's kind of doesn't help very much. Like for example this one. Or this one. Okay, let's see what the questions are. 5 plus 5 comes from prereq supply. Prereq comes from U703, which is driven from CD4051, and when on it comes straight from VREF. Yep. Reset delay time to make sure it's given enough time to settle. Well, we can power also CPU directly from SMU. Just connect 5 volts from SMU and see what that does. Like without providing power to everything else on the instrument. That should be easy to try. Let's connect the front panel back together. And I can try to find. So set the SMU to 5 volts. Same current limit. And let's see what's the power rail. So between the ground and so that's ground, that's power. Alright, so let's see that. And let me see actually. Okay. Okay. Now it's slightly different. So all the LEDs for the filters are off now. Battery is on, overload is on, but no other LEDs doing anything. And power draw is about 146 milliamps. I can hook up the scope and try to see the signals. Let's see. Yep, nothing on memory chip. Oh, there is some high potential here. I guess probably the reset is on. Let's see the reset. Yep, reset is low. So now I can short the reset too high. We can try that as well. Let me find some jump wire to try that. It's kind of brute force in our way. I'll just tie the power +5 to output of that reset inverter. Okay, now provide power. And the same thing. So a bunch of LEDs on filter shows up, battery overload, and low pass, both of the LEDs are on. No reaction to buttons. And let's see the signal waveforms. Still crazy. So, and let's see the power rail. Yep, still same ripple. And this is our reset. This is clock. And here's the 5 volt, nice and clean, because it goes directly from SMU. So, something digital. I guess the thing that I can do now quickly is just to remove the memory chip and see if the signals change. But that's probably about it for this live stream. So I'll check those links for the probably something short in on digital side, because it's not just the D2 line, some others are crazy too. So I would say something wrong either with the CPU or memory or one of the logic chips around. I was hoping this would be a quick repair, but seems like we'll need to dig a bit deeper into it. Which is okay, makes it interesting, and I'm looking forward to write an article about all this stuff. Would be pretty cool. So the manual that I have is revision 3 from 8.13. So there is it. I downloaded it from my server, so probably worth to take a look on the older revisions, if there are any. Oh, I see the schematics with the board file. Slightly different than one I have, because I don't have the board file view. Okay. That's handy. Maybe it's higher resolution too. How can I download from this archive.org? I want to download this manual. Here, download options, just as PDF. Okay, it downloaded. Cool. This will be handy. Let's save it up. SRS. Gotta preserve the archives. Looks like the same crappy quality. Which one? Doesn't say the revision, but looks pretty much the same. So the DAC is driving some stuff for filters, offset cancellation. What else? What model? Power button. 3D model. Okay, my power button is still fine. Oh, front panel 3D button. That's cool. Oh, there is a revision 3.1 for the manual. Okay, fairly recent, 2023. What's RF 3.1 user manual? Let's see what's difference. Caution. Everything looks same so far. They added schematics and block diagram into the manual, which is actually very nice. I wish more manufacturers would include the schematics and at least the BOM list. So that is nice. Appreciate standard research systems for doing this. Thumbs up for all the owners of the instruments they have. Also revision 2.8. Let's see what's different. Yep, have just the BOM list, no schematics in 2.8, which is alright. Well, I think that's all there is to it. Are there any other links I missed in the chat? So I'll take a look on that battery. I hope we can find firmware. Maybe somebody have the firmware or have the SR560 that we can dump the firmware from. because I'm still not 100% sure that original firmware is okay. May want to check if you can lower signal to chip select. I'm not sure what that means. Lower signal to chip select. You mean to select the different CS pin? Looks like just a pull up for a RAM chip from power, toggled by the reset. And the CS, well, there is no much other CS's. And I'll take some very high resolution photos of the board. By the way, the PCB on this unit bears mark part number 7-00222-701 revision G from February 1991. So that's what's on the seal screen of the PCB. And I'll also investigate this NPD 564 JFET. What is it in terms of if we can buy a suitable replacement, or if I can use some LSK linear systems dual JFET in there. But that would be after we fix the digital section. That's about it. I think there is nothing else I can try. Just need to get some more parts and can play around with the instrument some more. Yeah, I'll check other YouTube channels and also search online for SR560 to see what other people findings were. Maybe somebody actually already dumped the firmware. I can also probably order some of these logic chips around the digital CPU circuitry. They are pretty cheap these days, and we can just replace them instead of spending time to check the signals levels on them. Almost got it. Alright, this is already 1 AM in here, and it was an interesting investigation. So thank you everyone for stopping by, and I'll make more photos and upload them in a draft article in xdevs.com/fix/SRS560. So I'll put all the information out there. So hopefully we can fix it sometime next time. Alright, thanks for watching.